Let's look at practice problem on theory of errors. If you have not watched my previous video on theory of errors and its explanation, check the link in the description box below for the video. So watch it and attempt this problem. After watching it, you can attempt this problem and pause the video. So when you are done, you can continue. Question 1. Which of the following statements is correct about determinate errors? The first one, we have determinate errors are also known as random errors. The second one, determinate errors are irregular and variable in magnitude and sign. Option C, they cannot be they cannot in principle be corrected for. Option D, they are known as systematic errors. So looking at this, what's the right option? You will know that which is the right option? Option D. They are also known as what? Systematic error. It is like that because look at it. Determinate error are also known as what? Random error. No, it's indeterminate errors that we call random error. Next one, determinate errors are irregular and variable in sign. No, this is not its characteristic. Next one, they cannot in principle be corrected for. Remember that what in that determinate errors can be corrected for, but indeterminate error cannot be corrected for. So this one that is here now is a characteristic of what? Of indeterminate error. So the answer for this is option D. Next one, which of the following statements are correct about indeterminate error? First one, indeterminate error are also known as random error. This is correct, so I is correct. I'll write my I down. Next, indeterminate errors are irregular and variable in magnitude and sign. This is not part of the characteristic. Let's go to the third one. They can be due to the fluctuation of temperature. Okay. Option D, they are known as systematic error. This is wrong. This systematic error is for determinate error. Next one, they can in principle be corrected for. Never. This is not what? This is not correct. Now look at option II. Indeterminate error are irregular and variable in magnitude and sign. That's correct. That is very correct for II. So that's correct. They are irregular. Do you know why? The thing is that indeterminate error are caused by uncontrollable factor. So values can just fluctuate up and down, up and down, up and down. Let me explain something. You see determinate errors, they are unidirectional. They are unidirectional. While indeterminate errors, they are what? Bidirectional. I will explain that. You see, the unidirectional means that what? The error occur in only one direction. For example, just like the explanation I gave that if you have a scale pan that is used to measure the weight of objects, and then you have a mass that is on it, or let me say this weight, this instrument is reading 0.5 heavier than anything you put there. Or let me say is measuring 1 gram heavier than everything you put there. So if I have the mass of an object to be 3 gram, for example, if this one is 3 gram, by the time you put this 3 gram here, you have 4 gram. Everything you measure will always be added 1 gram. You can see that what is occurring only in one direction, that is 1 gram plus, 1 gram plus, 1 gram plus. But for indeterminate error that is bidirectional, this one, the value will just be fluctuating, both increase, decrease, increase, decrease. Are you there? That's why if you plot it, it will always give you something like a Gaussian curve in statistics like this, exactly. So take note, that's it. So that's why this II is correct. Indeterminate error are irregular, and yes, they are irregular, and they are what? They are variable in magnitude and sign. Okay, that is, it can go up, come down, go up, come down. So this II is correct. So the answer is option A. Next question. The following are determinate errors except dash. Okay, let's look at this. The first one here, they said a burette whose volume reading are in error by different amounts. Yeah, and remember this is a determinate error, but we are asked to say the one that are not determinate error. Okay, this is a determinate error. It falls under instrumental error. Next one, II, impurity in reagent. It falls under reagent error. Mathematical error fall under what? Does it fall under any of them? So just leave it separately. Next one, IV, corroded weight is under what? Is under instrumental what? Error. Because when the weight have corroded, it will affect its sensitivity. Next one, vibration in an instrument caused by passing traffic. Is this a determinate error? No, this is not a determinate error. So we have to choose this one that is not a determinate error. Noise and drift in an electronic circuit, indeterminate what? Error. So the series of the following are determinate except, so let's see. Okay. See, any option you see I and II will be wrong. Any option you see I and II will be wrong. So let's see. Anywhere you see IV also is also wrong because those are for determinants. Then this will be the correct answer. You can see how to solve this type of question. Firstly, the correct ones that are here, anywhere you see it, they are wrong. So these ones that are required for us to find, anywhere you see it is correct. Next one. In what ways can you minimize determinate error? Remember, this is correct. Calibration of apparatus and application of corrective measures. This is correct. Next one, running blank. Remember determination, blank, parallel, and control determination. Use of indicator to determine the endpoint. This is just a procedure for an experiment and it's not a way to minimize error. So this is wrong. A and B, correct. C is wrong. Anywhere you see option C is wrong. So the answer is what? Option D, A and B. Next question. Check. They said, which of the following is true of indeterminate error? They are bidirectional. Yes, remember what I told you? That indeterminate error deviates in both direction. It causes both increase and decrease in a value. Are we together? That's why we call it bidirectional. Okay, good. Or you hear that another word for bidirectional is unbiased. Good. Unbiased means that what is going in all direction. You know, when someone is unbiased, he's having equal treatment on all of them. So this one is affecting both up and both down. But determinate error that is unidirectional, it can just be adding. It's going up but not down. That's that. Next one, they are unidirectional. This is wrong. Next one, they can be attributed to concrete causes. Remember? No, no, no. This is not for this. Attributed to concrete causes. No. They cannot be eliminated. Yeah, that's indeterminate error. They cannot be eliminated. So let me just use the opportunity to just tell you some characteristics of indeterminate error. You can write them down. It is random, bidirectional, it is not measurable, it is not assignable. You cannot attribute it to something. Are you there? And it is always present, always present. You can never eliminate, always present. It cannot be eliminated. Okay, it cannot be what? Eliminated. It does not affect accuracy. Okay, but it affects precision. Indeterminate affects precision, not accuracy. The one that affects accuracy is determinate what? Determinate error. Take note of that. Okay, so that's that about that. Now let's look at this question. Look at this. Look at this. Now, look at this question. You know that we have different examples of error listed here. So I want you to tell me, is it a determinate error or indeterminate error? Now, I will do just one of these. Then you comment the three in the comment section below. Okay, let's go. Let me look at the one that is more challenging. I don't know. Okay, let me say I want to do this IV. Now, this is how you do it. If you choose determinate error, you have to tell me what type of determinate error is it. And if you are choosing indeterminate error, you don't need to put any type because indeterminate error are just random. So let's go. During acid and base titration, an analyst who is expected to put the acid in the burette and the base in the conical flask did the reverse of this. What type of error is this? Is it determinate or indeterminate? Firstly, you see that this analyst is inexperienced because number one, we are to pipette base into a what? Into a conical flask. We are to pipette base into a conical flask. But this analyst is doing the reverse. It shows that this person does not even know what how to carry out titration. So this is an example of what? This is an example of determinate error. Determinate error. And what type of determinate error is this? Operative error. Is it operative? Yeah, operative error. Yeah, operative error. Because due to the carelessness, or at times the person can know, and the person should be careless. Or at times, the person might not even know what to do. So this is what operative error. So inexperience of the what of the analyst. So that's that about that. So comment this theory on the comment section. Is it determinate? And is determinate tell me what type of determinate is it? Is it instrumental or operative? Is it personal error or error of method? So that's that for that. So thanks for watching. Try to subscribe, like, comment, and share to your friends.